Good morning, good afternoon, good evening, whatever the case may be. We are back in better than ever, and we are doing trigonometric equations, part 2. Picking up right where we left off. Fastball the way. Let's learn the way, shall we? All right, here we go. So we left off solving this equation. Sine x equals -1/2, and we found for 0 to 3 pi, and we found our solutions to be 7 pi over 6, which is right here, and 11 pi over 6. Okay, so now we have to think about sine of 2x equals -1/2. So this was part A. Let's label that. Okay, so now let's do part B. Okay, so we have sine 2x equals -1/2. Okay, and instead of x, like we had here, we have 2x. So let's think about that. We know that sine is equal to -1/2 at 7 pi over 6 and at 11 pi over 6. So whatever we're taking the sine of, which in this case is 2x, we have to end up with 7 pi over 6 and 11 pi over 6. So I need 2x to be equal to 7 pi over 6, because if it is, I'll have a true statement. Now, what we also have to consider is that if I start at 7 pi over 6 and make another trip around the unit circle, which is a distance of 2 pi units, I'll be right back where the sine is equal to -1/2 again. Okay, so I have to consider that. So I should say, oh, okay, so that would be plus 2 pi, right? Well, for a second, let's just pretend there's no domain. We're trying to get all the solutions. Well, once I travel around 2 pi, I could do it again, another 2 pi. So I could add another 2 pi, and that would be true. I would still be back where sine is equal to -1/2. And I could keep going and going and going, right? Well, there's a better way to write that. This is just 2 pi plus, if I just had these two, it would be 2 pi times 2, or all three, 2 pi times 3, 2 pi times 4. So the way I can write that is like this: 2 pi times k, where k is an element of the integers. And integers, remember, are like -3, -2, -1, 0, 1, 2, and 3, because I can only have whole integer multiples of 2 pi, so this is true. Now, we have to do the same exact thing for 11 pi over 6. So I'm going to say 2x is equal to 11 pi over 6 plus 2 pi k, an element of the integers. Okay, so now we have to solve for x. I'm not solving for 2x, I need to solve for x. So I have to divide everything by 2, yes. The 2's cancel here. X is equal to 7 pi over 6 divided by 2 is 7 pi over 12 plus 2 pi k over 2. The 2's cancel and I get pi k. Okay, same thing here. I'm going to divide both sides by 2, and in this case it would be 11 pi over 12 plus k pi, or pi k, whichever way. Oh, I guess I did pi k over there, so I might as well do it here. All right, so now we just start entering integers. So I'll say for k. So for k equal to 0, x is going to equal 7 pi over 12 plus pi times 0. Well, anything times 0 is 0, and I get my original 7 pi over 12. That makes sense. I check to see if it's in the specified domain, and it certainly is. Then I'll try k is equal to 1. So x would be equal to 7 pi over 12 plus pi times 1. Okay. Well, in order to add pi with a fraction of 12, I can rewrite pi as 12 pi over 12. And 7 pi over 12 plus 12 pi over 12 is equal to 19 pi over 12. And 19 over 12 is still less than 3, so I'm still within the specified domain. So for k equals 2, same idea. X equals 7 pi over 12 plus pi times 2, so that's 2 pi. But 2 pi written with the denominator of 12 is just 24 pi over 12. So that's equal to 31 pi over 12. There's another solution. Okay? But take a look at this pattern. Once I figure out what I add for the first one, I just have to add that to successive answers. In other words, 7 pi over 12 plus 12 pi over 12 is 19 pi over 12. 19 pi over 12 plus another 12 pi over 12 is 31 pi over 12. So I can still do this systematically, but once I hit the pattern, I can do it again. So this is still in the domain because it's less than 3 pi, okay? And so if I add another 12 pi, I'm going to be beyond 3 pi because 3 pi is equal to 36 pi over 12. So if I add another 12 pi over 12 to this, I'm going to be beyond 36 pi over 12. So I know I can stop here with my values of k. Now you should also always check k equal to -1 because you can go backwards too. These are just integers. Okay? So with k equal to -1, I would get x equals 7 pi over 12 minus pi or plus pi times -1, which is actually minus pi, right? Okay, which is actually minus 12 pi over 12. But 7 pi minus 12 pi is a negative number, which is out of the range. So I can stop right there with the negative as far as this one is concerned. And you might think, well, is that always going to happen when your lower bound is 0 on the range? No, sometimes you can use a negative integer to get, a correct answer. So again, k equals 0 here. I get x equals, and let's try and do this in our heads now, 11 pi over 12 plus 0, because pi times 0 is 0, equals 11 pi over 12. K equal to 1, okay, so that means that x is going to equal 11 pi over 12 plus pi times 1, or pi, or 12 pi over 12. That's equal to pi, which is equal to 23 pi over 12. And you see we have the same pattern, right? 11 pi over 12 plus 12 pi over 12 is 23 pi over 12. So when k equals 2, x is simply going to equal 23 pi over 12 plus 12 pi over 12. And I'll write that down, even though we should be able to do that in our head, which is 35 pi over 12. Okay, and remember, 36 pi over 12 is our upper bound because that's equal to 3 pi. No way I can add another 12 pi over 12 and get it. So I have all my answers. This one, this one, this one, this one, this one, this one. 6 solutions. So you have to be very, very careful. Okay. Now we should also try -1 here, but you can clearly see that 11 pi over 12 minus pi for k equal to -1 is going to be a negative answer, which is outside of the domain stipulated here. All right, let's have a look at this. Okay, find exact solutions of √2 cosine x minus 3 pi over 4 plus 1 for 0 to 6 pi. All right, so let me go ahead and rewrite that. Square root 2 cosine of x minus 3 pi over 4 plus 1 equals 0. Subtract 1, √2 cosine x minus 3 pi over 4 plus 1 equals 0. √2, why did I do that? I want to subtract 1 from both sides. That equals -1. Then I divide by √2, so I get cosine x minus 3 pi over 4 is equal to -1 over √2. And maybe that's not recognizable to you, but if I rationalize the denominator by multiplying both by √2 over 2, I end up with cosine of x minus 3 pi over 4 is equal to -√2 over 2. Okay. So where is cosine equal to negative root 2 over 2? If I look over here, oh look, they're already in this form of negative 1 over root 2. But pretty much the majority of books and exams write the pi over 4s as root 2 over 2. Anyway, this is cosine is negative root 2 over 2 all the way over here, which is 5 pi over 4. And also right here, which is 3 pi over 4. Okay, so that means that whatever is in here, x minus 3 pi over 4, has got to equal either 3 pi over 4 or x minus 3 pi over 4 has to equal 5 pi over 4. And just like we talked about before, we have to account for going backwards and forwards in multiples of 2 pi. Okay, so we do that by saying plus 2 pi times k, an element of the integers, 5 pi over 4 plus 2 pi times k, an element of the integers. Okay. All right, so now we have to solve. So I'm going to add 3 pi over 4 to both sides here. And I get x equals 3 pi over 4. 3 pi over 4 is 6 pi over 2. So that's 3 pi over 2 plus, that doesn't affect the 2 pi k, so it's still 2 pi k. And then here, x would equal, let's see, this would be 5 pi over 4 plus 3 pi over 4 is 8 pi over 4, which is 2 pi. Yeah, that's easy. Plus 2 pi times k. All right, so let's check them out. Remember, I'll write it here. My domain is for 0 less than or equal to x less than or equal to 6 pi. Okay, so let's think about that. So this becomes easy peasy. So k equals 0, then x is going to be equal to 3 pi over 2 plus 0, because 2 pi times 0 is 0. So we have 3 pi over 2. For k equal to 1, this is where we're going to find out all we have to add to each of our successive answers. 3 pi over 2 plus 2 pi times 1 is 2 pi. But I need this with the denominator of 2, and 2 pi with the denominator of 2 is 4 pi over 2. So that's equal to 7 pi over 2, which is well within my, my domain. Now, you want to do the same denominator, just so you know your limit. You want to use the same denominator for the end of your domain as the denominator you have here, so you can be careful. All right, so it has to be always less than 12 pi over 2. So for k equals 2, I'm just going to add another 4 pi over 2 to my preceding answer. So that would be 7 pi over 2 plus 4 pi over 2, which is 11 pi over 2, which is just below 12 pi over 2. So that works. Okay, so I've got 3 answers so far. And then we should probably check, you can check k equal to negative 1 in your head. 3 pi over 2 minus 2 pi is going to be negative. So I know that the k equal to negative 1 doesn't work over here. So k equals 0, this is a lot easier because I'm just adding 2 pi. 2 pi plus 0, x equals 2 pi. For k equal to 1, well, x is going to equal 2 pi plus 2 pi times 1 is 2 pi. 2 pi and 2 pi is 4 pi. K equal to 2, x equals 2 pi plus 2 pi times 2 is 4 pi. 2 pi plus 4 pi is 6 pi. And I'm right on the edge of my domain, so we're good there. But look what happens for k equal to negative 1. Well, x would be equal to 2 pi minus 2 pi, because k is negative 1 there, and 2 pi minus 2 pi is 0, which is part of the domain. Okay, and I can't go any further because then I would get negative values, so I know I am done. So I've picked up 1, 2, 3, 4 more answers. All right, well, just one more video to go on these trig equations. We'll get to that mañana. And so let's go back to fastball with the way. And with that, I am out.